Okay, we're going to do patterns and problem solving part 2. Finding a pattern is really a lot about guessing and observation. We're going to look at differences and then we're going to look at ratios. Okay, the finite differences are shown here with the pink arrows. So if I look at 0 minus 3 or 3 minus 0, I get 3. And then they continued. So each of these is a subtraction to find the difference. Now, these are finite differences because they have a pattern, but they take 2 levels of difference. So these were not the same. So I subtracted again, and I noticed that all of these have a difference of 2. Now I can use that to go backwards and say 9 plus 2 is 11, and 24 plus 11 is 36. Now, if we use finite differences in these problems, we would get similar results. So I can subtract 5 minus 4. 5 minus 1 is 4. 14 minus 5 is 9. 30 minus 14 is 16. 55 minus 30 is 25. And 91 minus 55 is 36. Now, a student might recognize that these are perfect squares, so I know the next one's 49. But let me continue to show you what the differences would look like. I need to subtract again because these differences were not the same number. 16 minus 9 is 7. 25 minus 16 is 9. 36 minus 25 is 11. They're still not the same number, although I notice they're odd numbers. So I know that all of these have a difference of 2. Okay, now that I have the common difference, I can use that to add up. So now I'm going to add up. So 11 plus 2 is 13. 36 plus 13 is 49. 91 plus 49 is 140. Okay, when kids first learn counting, they're learning a sequence with a common difference, 1, 2, 3, 4, and then they learn skip counting, 2, 4, 6, 8. They might even learn skip counting by 3s or by 5s or 10s. Those are all common difference sequences. In math, we also call them arithmetic sequence, and these are also linear. So think about that, write that down in your notes. Right, the first sequence has a common difference of 4. 7 plus 4 is 11, plus 4 plus 4 plus 4. What is the common difference for the second sequence? So we would need to subtract these, write the next 3 terms in each sequence. So if we're going to add 4 each time to the first one, we're going to get to 27, 31, and 35. Okay, for the second sequence, I need to subtract these. Okay, that's 84. And then I'm going to come over here, because it told me it was a common difference, I'm just going to come over here to the end and start adding 84. So this should be 592, and then add 84 and add 84 to get the next 2. That's a common difference. All right, there's another kind of sequence that uses a common ratio, so multiplying by the same numbers or dividing by the same number. It is a geometric sequence. In algebra, it is exponential. Okay, so hopefully you remember exponentials a little bit from algebra, from college algebra. All right, so this time the common ratio in the first sequence is 2. So common ratio means we're either multiplying or we're dividing, depending on if it's getting larger or smaller. So if I multiply 3 by 2, I get 6. Multiply by 2 to get 12. Multiply, multiply. What is the common ratio in the second sequence? So if you can't tell what it is, let's pretend we don't know it's 5. take the two numbers and divide. So 5 divided by 1 is 5. Then try it for another pair. So maybe I'll come over here and use my thinking skills and say 625 divided by 125 is also 5. Okay, once you know that common ratio, because we got it by dividing, then we should be able to multiply and get the next ones. If I multiply 48 by 2, I get 96 times 2 is 192. On the second sequence, 625 times 5 is 3,125, times 5 is 15,625. Identify each sequence as arithmetic, geometric, or neither. So there's a lot of sequences that are not one of these. So remember that arithmetic is going to be plus or minus, depending on if it's getting larger or smaller. Geometric is going to be multiply or divide, depending on if it's getting larger or smaller. And then everything else is neither. So let's start at the first one. I know that 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And the pattern continues there. So if I multiply by 3, I would get the next numbers. And so I'm going to mark this one as geometric because I multiplied by 3 every time to get my next number. All right, I'm going to skip the middle one for just a minute. Number 3. I don't know the multiplication facts for these, so I'm going to start with subtraction. 55 minus 43 is 12. 67 minus 55 is 12. And then just do a quick check. That works every time. So I'm going to add 12 to get the next number, and then add 12 again and add 12 again. This one is going to be arithmetic. Okay, the middle one is neither. It is actually the sequence of perfect squares, which is a quadratic formula. We don't have to know that in this class, but it is quadratic. And so I know that the next one is 6 squared is 36, 7 squared is 49, and 8 squared is 64.